You're listening to CFI.
This is all there is to the Walmart glider. Pretty simple. Two wings, tail, and a fuselage. Haven't changed much except you can see the slight alteration to the elevator portion of the tail. The entire airplane is vacuum molded out of styrofoam, and of course, since it's pretty cheap, it's got an awful lot of casting marks on it, and the whole surface is very rough. So I've taken some 220 sandpaper and I've sanded the entire surface of the aircraft to smooth out all the casting marks and give a little bit smoother surface. I also made a little extra bevel on the front leading edge. It was pretty blunt, and cleaned up the trailing edge for all of the aircraft. Even the fuselage had an awful lot of casting marks sticking out, and the tail was probably a half inch or 3/4 of an inch wide, just a blunt surface. So I tapered the front of the vertical empennage to make it a little bit more aerodynamic. This is the tail section and probably has the most alterations of all the parts of the aircraft. It is a V-tail, and to make an elevator with that, I need 2 servos to keep the angle. I disposed with that. I used an elevator from a crashed Radian, badly crashed, and cut the tail so it was straight across, and used some microderm as hinges. I had to cut out a little bit here and put a bevel on the bottom side and microderm both edges using the original horn from the Radian. Microderm's the tape I used. You can buy this in the hobby shops for a couple of dollars a roll. It's microderm medical tape, and if you buy it online, say from Amazon or even Microderm, you can get this for about 79 cents a roll. But you have to buy a box, and it'll last you your entire career. So that's the tail, again sanded, and the servo is going to be connected again from an old Radian piece up this rod, and the servo is going to be up near the center of gravity because in the back it's just way too tail heavy to put it here. So it's going to be moved up near the center of gravity.
This Walmart glider has a tapered wing which presents a challenge to force management compared to that of a straight wing. To understand how to place the motors and predict the balance points for flight, I made a series of precise measurements of the wing and transferred those to an application called GeoGebra to model and visualize the wing's parameters. From those measurements, I used a mean aerodynamic chord calculator to further understand the wing's dynamics. It turns out the wing is a Clark Y. All of this information is used to design and place the nacelles.
Here's the complete electronic package for the glider conversion. Everything is leftover parts from other RCs except the 2 RCX 13008 5 kV motors and props. That's new to me, and I'm not sure what kind of power they're going to produce, but on a test bench they seem to be pretty good, so I'm confident they're going to be able to pull this little aircraft along. I know together they're all doing about 100 watts, so that's pretty good.
Attaching those small motors to a thin tapered wing presented a challenge. I used a CAD program to design motor mounts that would attach them in a seamless fashion and incorporate the taper of the wing itself. As you can see, they look pretty good. This conversion will be controlled with a Taranis radio coupled with an FR Sky receiver. 3 channels will be used, 1 for pitch control, 2 for differential power that control both altitude and yaw-induced banking turns.
Well, as you can see, I've got the aircraft all together. Those piles of parts that I showed you have now been amalgamated into a single product. Along the way, some improvements have been made to the design. Motors are on the wingtips. You can see the nacelles. I routed the wires in channels. I didn't channel them on here because this portion doesn't produce very much lift. The center of gravity is along reinforced tape here which stiffens the wings quite a bit. The servo for the elevator is in front. This is a perfect balance at this point. Receiver is here. I'm running 2 ASCs. The battery compartment is routed out here. And it all works fairly well. I've not flown it yet, but as you can see, it seems to be ready to go. I did give it a toss after I balanced it with just the servo and the elevator, level them out, and it flew nice and level. So that was at the balance point. So this balances within 0.2 grams of nose heavy. So I'm suspecting we're going to have a fairly good, or at least a stable flyer for now. I did try the motors out. The motors are pretty powerful despite their size, and the twist moment they'll create is pretty large, so I'm going to have to tweak the curve on the radio to kind of tone down the amount of power I get out of each motor during a turn, or to induce a turn yaw motion. So it's ready to fly. Looks pretty good. Wish they're a little bit more sturdy, but that's a function of this styrofoam. This is not EPO. So there we have it. The challenge is ready to go.
These test flights revealed some design and assembly flaws. The right motor screws backed off, making its thrust direction undefined. While correcting this, I also set up counter-rotating props. Both changes should reduce the left-turning tendency that seems to be plaguing launch and landing. These changes in place make the Challenge bird a new machine all over again.